Alright, okay, this will be another examples for stationary point or relative extremum point. So given that this is a function, okay, and this function x cannot accept 2, right? Any value but x cannot be 2, alright? So find the coordinates of the stationary point. Okay, the question is just asking you to find the coordinate of stationary point. So then you don't find the critical points, as the critical points is include the case where f prime x is 0 and f prime x, the first derivative is 0, or f prime x is undefined. So in this case, it specifies that they just want stationary point. So it means that you have to find f prime x and equate this to 0. So to differentiate this, you have to use the quotient rule, right? Quotient rule. So as you're very familiar with quotient rule, then you have v, right? V, quotient rule, we use v u prime, right? V u prime. Differentiate. You have 2x minus 2. So v, differentiate up, u prime, x squared, do 2x minus 2. And then minus with u v prime, right? U x squared minus 2x plus 4 v prime. Differentiate x minus 2, you have 1. Then everything over with x minus 2 to the power of 2. Alright? So if you rearrange this, you are getting, for on top, you have to, alright, you have to expand, okay, expand. So expanding, okay, or I want to find the relative max, okay. So we go and expand this whole thing, so it will become 2x squared, okay, 2x to the power of 2, right, 2x to the power of 2, and minus with 2x, okay, minus with 2x, 2x squared, minus with 2x, minus with 4x, plus 4, right, plus 4, minus x squared, negative, negative, positive 2x, and negative 4. Okay, we simplify the numerator. So we're getting 2x squared minus x squared, 2x squared minus x squared. We have x squared. Okay, we have x squared. Then negative 2x plus with 2x, you are getting 0. Then you will still have remaining one, negative 4x, right? 2x squared minus x squared, you're getting x squared. Negative 2x plus 2x, 0, and negative 4x. And then you have 4 minus 4, right? 4 minus 4, you are getting 0. So then you will have x minus 2 to the power of 2. So this is your first derivative. Okay, your first derivative. So means I'm going to use this first derivative to find the stationary point for this curve here. Okay, stationary point for this curve, or we want to find the relative extremum point. So end up equate the f prime x, we equate the gradient function, the first derivative equal to 0. So means that x squared minus 4x divided by x minus 2 squared equals to 0. Okay, a fraction equals to 0 means that the numerator must be 0. In order for this whole thing to be 0, the numerator must be 0. So therefore, your x squared minus 4x have to be 0. Right? So you factorize, you have x minus 4 equals to 0. Then you're getting two stationary points. You have x equals to 0, you have x equals to 4. Where these 2 points, you have stationary point. So then further, we want to know that this point, is it a relative maximum or relative minimum point, right? So before, we have to find the coordinates, right? The coordinates of the stationary point. So this is the stationary point. X equals to 0 and x equals to 4 is the stationary point. So we want to find the coordinate of this point. So then we substitute 0. So when x is 0, your value of y, right? According to here, this is your y. So it's substitute. You have 0 power of 2 minus 2 times 0 plus 4 divided by 0 minus 2. Right? 0 minus 2. So you have 4 divided by negative 2. You have negative 2. Right? Negative 2. So you have coordinates 0, negative 2 as the first stationary point, and following by x equals to 4. Same thing, you're putting back into the function to find the value of y. So you have 4 square minus 2 times 4 plus with 4 divided by 4 minus 2. So then you have 16 minus 8 plus 4, right? 16 minus with 8, sorry, 16 minus 8, you have 8, right? 8 plus 4, you have 12. So 16 minus 8, you have 8. 8 plus 4, you have 12. 12 divided by 4 minus 2, 2. So you're getting 6. So means that 0, negative 2, and 4, 6 are the stationary point, right? Stationary points of fx. So now from the first question, I already get the stationary point. Stationary point means stationary, pegun, okay, tidak bergerak, not no movement. Means the dy dx, or we said that the dy dx is 0, the f prime x is 0, right? The f prime x is 0. So means that the gradient at that particular point, the gradient of tangent is parallel to the x-axis. So this is then I already find the stationary point. So now of course they were asking you to determine whether it's a relative maximum or minimum. I don't know which one is maximum or minimum. So we have to choose a test. So there are two tests that I already introduced. The first one will be the first derivative test, and the second one will be the second derivative test. So for this case, you can choose either one because they never state that you need to use any test. So you have to just choose a suitable test. So for this case here, if you apply second derivative test, then you have to apply the quotient rule again. Maybe it will end up with something very complicated. So for me, I will try first derivative test for this case. Okay, so in these cases, I'm going to choose the second derivative test as a test. So let's see. Alright, okay, now I'm going to apply the first derivative test. Okay, so you can choosing second derivative test if you want. So alright, so this case we have 0 and 4. 0 and 4 as a stationary point. So then between this we have, okay, I just writing here 0 and 4. Okay, 0 and 4, which divide them to 3 interval. Alright, 3 interval where negative infinity up to 0 and 0 up to 4 and 4 up to infinity. So then usually I will draw this table into 3 rows where this is the interval of x, right? Interval of x, and this is the sign of f prime x. Okay, the sign means positive or negative, and this is the shape of tangent. Shape of tangent means the characteristic, okay, the nature of the. So now I'm going to determine whether positive or negative. So this is the first derivative test. So I'm using the first derivative. So to be fast, I can using my calculator to test the value, right? I can using this calculator. So you key in this gradient function. So you have alphabet x to the power of 2, right? Minus with 4 alphabet x, right? Just key in so that they don't need to repeat and putting all the number, right? So alphabet x minus 2 to the power of 2. So I have key in this function in my calculator. So I make use of the calculator, the technology. So then now I want to put a value, right? If I'm not using calculator, I'm going to substitute one by one. It's getting very tired. So now it's just a test, so you can using your calculator to identify the positive or negative. So choose a number less than 0. I choose negative 1, right? So I key in negative 1. Okay, sorry. So after that, you key in, you have to pressing the button calculate. Alright, then you key in negative 1. Negative 1, you pressing double equal, then you get a positive number. Let's see that it's a positive number. So it means that you substitute negative 1, you're getting a positive number of 5 over 9, right? The sign is positive number. So, alright. So now I will be checking for between 0 and 4. So I will choosing 1. So I calculate So I just choosing a number that, but be careful about this problem. This problem is very different from polynomial function because there is an asymptote here. You don't choose beyond 2. You don't choose because x equals to 2 is a vertical asymptote. So from your knowledge of limits and continuity, this is knowledge of asymptote, this is an asymptote. So you don't choose 2 or 3, right? Because if you're choosing 2, this will be undefined, right? So you don't choosing 2. And you don't choosing 2, 3, 4. After 2, don't choose. You choose nearer to 0, for example, 1, right? 1. So 1 is not passing 2 yet. So you calculate 1. 1, then equal. Then you have negative number. Negative number. Alright? And followed by after 4. After 4 is okay. You can choose any number. Why? Because x equals to 2 is not inside this range. It's not, it's an asymptote. So if x equals to 2 is inside the range, so you don't choose the number after 2. You choose from 0 up to 2, the number between 0 and 2. Okay, be careful for this case when you use, because this is asymptote. So 4 to infinity. So you calculate 5, for example, 5. Okay, and you're pressing equal. I'm getting a positive number again. Okay, I'm getting a positive number again. So now I have enough evidence. Okay, I have enough evidence to show that this is a positive, is a relative maximum or minimum. So look at here, positive, right? Positive and negative. So if you're joining this, you will see this stationary point. This is a relative maximum point. And for 4, you see, it's negative followed by positive, right? Positive. So this is a relative minimum point. So I have to state 0. So belong to 0, negative 2. Based on the first derivative test, so it's a relative maximum point. Okay, relative maximum point. And 0 and 2 and 4, negative 6. 4, 6 is a relative minimum point, right? Minimum point. So, all right, you have relative maximum, you have relative minimum point. If you have a knowledge for asymptote, like I am teaching you before in the previous video about limit x approaching 2 plus, 2 minus, the horizontal asymptote, you have everything and you have all this, you can sketch a very perfect graph. Okay, excellent. So now, okay, I'm not going to sketch the graph for you. So I will tell you that I will be using Desmos to check whether this is true or not. So Desmos, so okay, remember these apps. So then you key in this function, So this is the graph, right? So put bracket because you have to key in the whole thing. This one divided by this one, the quadratic. So it's x power of 2. X power of 2, right? X power of 2 minus with 2x plus 4, right? Okay. Then you divided by x minus 2. X minus 2. Then you can see the graph. Okay, you can see the graph. So from far you can't see, you can zoom in. You can zoom in, you can zoom again. If you keep zooming, okay, from far you see this is the point, right? If you see carefully, there is an asymptote here. There's an asymptote here. So if I zoom for you, you can see that during 2, can you see? At x equals to 2, the graph going to negative infinity, right? If you see, it won't touch the line 2. And above, during 2 means 2 plus 2 from the right. The limit of 2 from the right from this function, it will reaching positive infinity. If you keep scrolling, you're getting very high and high. So now, okay, now this is not the case that I want to discuss. I want to discuss is the stationary point, right? So if you see that this is a relative maximum point, right? So if you see this point, it's going up, right? Going up, then going down. Can you see? This is a relative maximum point, the shape of relative maximum point. So if you see from far, you see nothing is stationary there, right? So but when you zoom in, So when you zoom, keep zooming, when you keep zooming again, then you can see at this particular point, 0, 2, 0, 2, you see there is a, like if you draw a straight line here, it's a horizontal line, right? So this is a stationary point. So, and another one, okay, and another one will be 2, 4, 6. 4, 6 is a maximum point. So you're going up here, and then you see there is a point here, right? From far you can see, okay, this point. So if you zoom, you see 4, right? You see 5. You see this is 4. Zoom again, 4. So when you move up, 4. When you move up, you see this is another stationary point, which is 4, 6, right? 4, 6. So it means I already tell you that this is a relative minimum point and this is a relative maximum point for this case by using first derivative test. Okay, for the same question, you can actually try second derivative test, but you have to differentiate this for one more time. So it will be a bit tedious. Alright, okay, see you for the next video.